Hello dear students, welcome to the lecture series on geography. In previous episodes, we discussed about hydrological cycle, origin of clouds and their types. Precipitation is an important step concerned with hydrological cycle. So, it is very interesting to know how water moves upward to the sky and how we get the rain. As such, precipitation is an interesting topic, and today we are going to discuss this topic under the following captions. They are definition of precipitation, formation, size and rate of precipitation, different classes of precipitation, precipitation measurement and effects of climate change on precipitation. Let us start with definition of precipitation. Precipitation in meteorology refers to all forms of liquid or solid water particles that form in the atmosphere and then fall to the earth's surface. Precipitation is defined as liquid or solid condensation of water vapor falling from clouds or deposited from air onto the ground. It is the primary connection in the water cycle that provides for the delivery of atmospheric water to the earth. It includes rain, sleet, snow, hail and drizzle, plus a few less common occurrences such as ice pellets, diamond dust and freezing rain. Frost and dew are not classified as precipitation because they form directly on solid surfaces. There are two types of precipitation, liquid and solid types. Precipitation in the form of ice flakes such as snow is called solid precipitation, and that in the form of water drops is sometimes called liquid precipitation. Liquid precipitation. Liquid forms of precipitation include rain and drizzle. Rain or drizzle that freezes on contact within a sub-freezing air mass is called freezing rain or freezing drizzle. Frozen forms of precipitation include snow, ice needles, ice pellets, hail and graupel. So, what is rain? Rain is drops of liquid water falling from the sky. In order for the raindrops to become heavy enough to fall, droplets of water in the cloud collide together with other droplets and other particles in the air like soot and dust to become larger. Once the drops become too heavy to stay in the cloud, it falls as rain. Raindrops can be up to 6 mm in diameter, but anything less than 0.5 mm is considered as drizzle. Drizzle consists of very small droplets of water falling from low level stratus clouds. Drizzle droplets are less than 0.5 mm in diameter, larger than the droplets in clouds, but smaller than raindrops. Freezing rain is rain droplets which fall in supercooled liquid form but freeze on contact with the ground or another object to form clear ice, also known as glaze. Supercooling occurs in clouds where droplets remain in a liquid form in temperatures below the normal freezing point. In order for the supercooled droplets to freeze on contact, the ground temperature is normally close to or below 0 degree centigrade. Next is solid precipitation. Hail is solid precipitation in the form of balls or pieces of ice known as hailstones. Hail only form in cumulonimbus clouds, more commonly known as thunderclouds. In thunderclouds, drops of water are continuously taken up and down through the cloud. When they go to the top of the cloud, it is very cold and they freeze. As the updrafts in thunder clouds are very big, they can keep these hailstones for a long time, so they get larger and larger by becoming coated with more and more ice. Then when they get really big, the updrafts in the cloud cannot hold them up anymore and they fall to earth, and by this time they are big balls of ice and so do not have time to melt before they reach the ground. Hailstones can vary in size from 5 mm to 150 mm in diameter. However, most hailstones are smaller than 25 mm. Another form of solid precipitation is ice pellets. Ice pellets are snowflakes which have started to melt and then refrozen as they fall through colder air. The result is a grainy snow pellet encased in ice. Snow is tiny ice crystals stuck together to become snowflakes. If enough ice crystals stick together, they will become heavy enough to fall to the ground. When coming to sleet, it has no internationally agreed definition, but it is reported in meteorological observations as rain and snow mixed. Sleet, which is sometimes known as ice pellets, is basically snow which has begun to melting process before it reaches the ground. Next question is, what is diamond dust? Diamond dust, sometimes just called ice crystals, consists of extremely small ice crystals usually formed at low levels at temperatures below -30 degrees centigrade. The name diamond dust comes from the sparkling effect created when light reflects on the ice crystals in the air. Next is formation, size and rate of precipitation. The clouds floating overhead contain water vapor and cloud droplets, which are small drops of condensed water. These droplets are very too small to fall as precipitation, but they are large enough to form visible clouds. Water is continually evaporating and condensing in the sky. If you look closely at a cloud, you can see some parts disappearing, that is evaporating, while other parts are growing, that means condensation. Most of the condensed water in clouds does not fall as precipitation because their fall speed is not large enough to overcome updrafts which support the clouds. For precipitation to happen, first tiny water droplets must condense on even thinner dust, salt or smoke particles which acts as nucleus. Water droplets may grow as a result of additional condensation of water vapor when the particles collide. If enough collisions occur to produce a droplet with a fall velocity which exceeds the cloud updraft speed, then it will fall out of the cloud as precipitation. This is not a trivial task since millions of cloud droplets are required to produce a single raindrop. Rain is the liquid form of precipitation on earth. It is part of the hydrological cycle that begins when water evaporates and forms clouds in the atmosphere. The water that forms these clouds is frozen and vaporized. Once enough water has evaporated, it is then released in the form of droplets of rain back to the surface of the earth. A stationary raindrop initially experiences acceleration due to gravity as would any falling body. As gravity increases, the speed of the raindrop in its descent, drag retards and downwards acceleration of the raindrop. Usually, air resistance that comes in contact with a water molecule as they fall cause the drag. The combination of these two forces causes a raindrop to reach a terminal velocity when the drag force is approximately equal to the weight of the raindrop. At this point, a raindrop experiences no further acceleration and therefore falls at a constant velocity. The magnitude of the terminal velocity of an object is also affected by its orientation. A common misconception is the shape of the raindrop. It is often depicted as pointy or lopsided. Precipitation rates vary geographically and over time. Precipitation does not fall in the same amounts throughout the world, in a country or even in a city. The Global Precipitation Measurement Corps Observatory surveys Earth's weather from 65 degrees north to 65 degrees south latitude. GPM works along with a constellation of other satellites to provide worldwide coverage. On the ground, precipitation can be measured by an array of rain gauges scattered around the world. From its 253-mile high orbit, the GPM satellite passes over almost the entire world. GPM circles the globe every 93 minutes, completing 16 orbits per day. GPM is one of the constellation of weather satellites. The satellite carries a microwave imager. Its scanning antenna rotates 32 times per minute, while a downward pointing detector reads microwaves reflected from the atmosphere below. As it orbits, GPM scans the Earth's atmosphere with its dual frequency precipitation radar. Now, we shall move on to different classes of precipitation. There are different kinds of precipitation: convectional, orographic, cyclonic and dynamic precipitation. Coming to orographic precipitation. Orographic precipitation results when warm moist air moving across the ocean is forced to rise by large mountains. As the air rises, it cools. This is because a higher elevation results in cooler temperature. Cold air cannot hold as much moisture as warm air. As air cools, the water vapor in the air condenses and water droplets form. Cloud forms and precipitation occurs on the windward side of the mountain. Then the air is dry and rises over the top of mountain. As the air moves back down the mountain, it collects moisture from the ground via evaporation. This side of mountain is called the leeward side. It receives very little precipitation. Coming to convectional precipitation. Convective precipitation is also known as thermodynamic precipitation. Convectional precipitation results from the heating of the Earth's surface. The warm ground heats the air over it. As the air warms, the air molecules begin to move further apart. With increased distance between molecules, the molecules are less densely packed. Thus, the air becomes lighter and rises rapidly into the atmosphere. As the air rises, it cools. Water vapor in the air condenses into clouds and precipitation. This type of precipitation is common in the prairies and Ontario. Next is cyclonic precipitation. Cyclonic or frontal precipitation results when the leading edge of the warm, moist air mass meets a cool and dry air mass. The molecules in the cold air are more tightly packed together, and thus the cold air is heavier than the warm air. The warmer air mass is forced up over the cold air. As it rises, the warm air cools, the water vapor in the air condenses, clouds and precipitation results. This kind of precipitation is common in Atlantic Canada. Cyclonic precipitation is also called frontal precipitation because the moisture tends to occur along the front of the air mass. A cyclonic storm is a large, low pressure system that forms when a warm air mass and cold air mass collide. This collision often occurs under the polar front jet stream, which spread cold, dry Arctic air near warm, moist tropical air. The rotation of the earth causes the air to circulate in a counterclockwise direction around an area of low pressure. Dynamic precipitation. Dynamic precipitation is also known as stratiform precipitation. Dynamic precipitation results from a forced lifting of air. These forcing mechanisms include processes that cause low level convergence and upper level divergence. As unsaturated air rises, the relative humidity of the air will increase. Once the air saturates, continued lifting will produce clouds and eventually precipitation. Dynamic precipitation tends to have a less intense rain rate than convective precipitation and also tends to last longer. Now coming to precipitation measurement. Precipitation is measured as the amount of water that reaches horizontal ground of the earth's surface and is expressed as a vertical depth of water or the water equivalent of solid precipitation. The unit of precipitation is the millimeter. Instruments for measuring precipitation include rain gauges and snow gauges, and various types are manufactured according to the purpose at hand. Rain gauges are classified into recording and non-recording types. The latter include cylindrical and ordinary rain gauges, and measurement of precipitation with these types is performed manually by the observer. There are different types of rain gauges to measure the precipitation. Some important ones are as follows. Cylindrical rain gauges. As this type of rain gauge can also be used to measure snow, it is alternatively known as a cylindrical rain or snow gauge. It consists of a cylindrical vessel with a uniform diameter from top to bottom and an orifice at the top. It does not have a funnel. Rainwater enters through the orifice and accumulates in the cylindrical vessel, which is weighed at regular intervals with a precipitation scale. As the amount of precipitation is determined by subtracting the vessel weight from the total weight, the dry vessel is weighed before observation. A rain measuring glass may be used instead of a precipitation scale. To measure solid precipitation such as snow and hail with such a device, a known amount of warm water is added to melt the precipitation. The total amount is then measured with a measuring glass, and the amount of warm water added is subtracted from the total to obtain the precipitation amount. The precipitation scale is graduated in millimeters based on the size of the rain gauge orifice. Ordinary rain gauges. Ordinary rain gauges are the type used at non-automated observatories. With such devices, the observer takes measurements using a rain measuring glass at regular intervals. This type of rain gauge consists of a receptacle, a shell, a storage bottle, a storage vessel and a rain measuring glass, which is a measuring cylinder graduated in precipitation amounts based on the diameter of the receptacle's orifice. The shell acts as a container for the storage bottle and the storage vessel. Rainwater entering through the receptacle accumulates in the storage bottle and the precipitation amount is measured with a measuring glass. Rainwater that overflow from the storage bottle enters the storage vessel. The amount of overflow is also measured with a measuring glass and is added to the amount of precipitation in the storage bottle. Next type is siphon rain gauges. A siphon rain gauge enables automatic continuous measurement and recording of precipitation. This type of rain gauge consists of a receptacle to collect precipitation and a measuring part to measure and record its amount. The measuring part consists of a float with a recording pen, a storage tank with a siphon to drain a fixed amount of water and a clock driven drum. Rainwater gathered by the receptacle is led from the rain receiver to the storage tank through an adjacent vessel. As a result, a flow Now, let us know what are the effects of climate change on precipitation. As temperature rises and the air becomes warmer, more moisture evaporates from land and water into the atmosphere. More moisture in the air generally means we can expect more rain and snow and more heavy downpours. But this extra precipitation is not spread evenly around the globe and some places might actually get less precipitation than they used to get. That is because climate change causes shifts in air and ocean currents which can change weather patterns. On average, the world is already getting more precipitation now than it did 100 years ago, nearly 2% more worldwide. The effects vary by region. In future, precipitation is expected to increase in higher latitudes and decrease in areas closer to the equator. This is the matter of concern because too little or too much water can be a problem. In many places, people depend on rain and snow melt to fill lakes and streams and provide a source of water for drinking, watering crops and other uses. On the other hand, heavy rain can cause flooding. Coming to effects on agriculture. The crops that we grow for food need specific conditions to thrive, including the right temperature and enough water. A changing climate could have both positive and negative effects on crops. Global climate change will also affect agriculture and food supply in many other ways. Climate change could make it too hot to grow certain crops, and droughts caused by climate change could reduce the amount of water available for irrigation. Climate change is also likely to cause stronger storms and more floods which can damage crops. Higher temperatures and changing rainfall patterns could help some kinds of weeds and pests to spread to new areas. Effects on water supply. Climate change is affecting where, when and how much water is available for people to use. Many parts of the world already have very little water, and climate change could make this problem more